Cool. So before we get started, I just kind of want to get an idea. How many of you are Java developers? Familiar with Java? It's pretty much everyone. How many of you have done some Android development? Okay, more than hello world? Got it. Cool. Okay. So basically, this talk is going to be about architecting Android applications. I'm going to tell you a little bit about myself first. My name is Marko Gargenta. I am an Android developer. Before that, I was a Java developer. I was doing Java before it was officially Java back in the day. And I kind of got interested in Android early on and started doing some development and then started doing some training on Android. And since then, I created a course for Maracana called Android Bootcamp. It's basically a 5-day course that takes you from knowing Java to about being able to create just about any Android application. Later on, I bottled that course into a book called Learning Android. And actually, I have some copies of that book here, so I'll be doing a little book signing afterwards for the first 20 people that show up. So just so you guys know. So that's a little bit about my background. I frequently speak at AnDevCon. This is, I think, my third year. And I'm doing another talk later on as well on NDK. So we're going to talk about what it takes to build an Android application. Basically, lines and circles, more from the architectural standpoint. I'm going to try to point out things that are sort of unique to Android, where Android departs from other languages like Java or other programming experience that you may have. So with that, what we're going to do is we're going to basically talk about the part one is going to be about activities in UI, how to use activities properly. Then we're going to talk about intents, action bar, and how to basically connect things together. Then we're going to talk about services, different types of services, content providers, what they are and how to use them, lists and adapters, broadcast receivers, and finally a little bit about web app widgets. So to kind of frame the talk, I have an application that I use as an example application so that you can kind of relate to different things we're talking about, so it's not as esoteric as it could have been. So the application that we use is called Yamba. Yamba stands for yet another microblogging application. It's basically a Twitter app. We just couldn't use the word Twitter because it's trademarked. So what I like about this application is that it basically in a very natural way showcases all the different parts of Android app development that are interesting, such as how do you build UI, how do you do background services, how do you deal with the data, how do you make the web service calls, etc., etc. So we're going to use this application as a context for the development for this talk, and we're going to basically build this application, at least in lines and circles, through 7 different iterations, and I'm going to explain those iterations soon. But first, let me just kind of quickly show you what that looks like. And this app is available on GitHub, and I'll give you a URL to that later on. But essentially, this is that mini application. So basically, you have a list of tweets, just like you would expect it to do. So there are lots of tweets from people all over the world that are reading Learning Android book and kind of following the book along. So there are lots of students using this application. We basically have our own service, so we're not using Twitter because Twitter really quickly shuts us down due to the rate limit when we have a lot of people using it with the same username and password, for instance. So we have our own service that we run at yamba.maracana.com, but basically adheres to the same Twitter API, right? So the idea is this is designed for learning, so we wanted to get the friction out of the way, and that's why we're on a separate service. So basically, what I can do in this application is I can see what my friends are doing. I can click on an update. I can basically say hello from AnDevCon, for example. Click on the little update button. This is now actually posting to the cloud, so it's making the web service call. It may fail because we have a spotty connection, but it says it succeeded right here. So if I go here and refresh this page, there's the post that we just got from that. From that application. So the application actually posted to the cloud, and we're able to verify that by pulling from the cloud. So I'm going to go back to my screen here, and I'm going to pull from the cloud and see what we got. So basically, there's the post that we just posted, hello from AnDevCon, right? So that's a simple application that we're going to basically talk about and use it as a context. So the first part, the first iteration is building UI and working with activities. So basically, in Android development, you have these 4 main building blocks that you use to build just about any application. So these are activities, services, providers, and receivers. So it's the combination of these 4 things that makes up any application. So the first one, the one that's the most obvious, is an activity. I'm using this graphical language here, but basically, just to really quickly explain what it is, the dotted line you're kind of seeing here, that represents our application. In Android, an application is really just a loose collection of these building blocks: activity, services, providers, and receivers. So basically, we're going to be throwing a bunch of these components into this box, and that's going to make up our application. So that's what the dotted line is. It's basically the app context. The gray box here represents our activity. It represents one screen. And that's going to be where we basically type in the status update, hello from AnDevCon, press the update button, and that actually makes the web service call to the cloud and post the message, right? So, like I said, the very first thing that we're talking about are activities, and I mentioned that activities are roughly screens, right? So they basically represent a single screen that you have in your application. Now, your application can have multiple screens at the same time. And you can have usually one screen that's the main screen, the entry point into your application. So it's sort of analogous to a website having multiple web pages and having a home page. So you saw a couple of screens in this application. You saw one screen here where we can basically see the list of our, the tweets from our friends. We can basically click on the update button, and we can, which is another screen, and we can post something. We can go back, go to, for example, preferences screen, update preferences, and so on. So it's basically like a mini website with multiple pages. Now, what's interesting about activities is that they are the most managed by the system. So the system considers them fairly expensive, and as such, it basically manages the life cycle of the activities. What that basically means is that you, as a programmer, you don't control the states that your activity is in, right? Which to some of us is sort of a new way of thinking, because most of us sort of are used to having a main method or main function, right, and kind of kicking everything off from there. In Android, it doesn't work that way, so it's all sort of event-driven. So something else is basically poking our application and calling the methods on our application. So initially, what happens is your activity is not running, right? So basically, you click on a button, you start the application for the first time. That consequently starts your main activity, the entry point into your application. And your application then goes to what we call a running or visible state. That means that it's on the screen interacting with the user. You can only have one activity in this state ever, right? So there's only one that's actually interacting with the user at one point in time. In terms of memory management and priorities and such, this activity gets all the power, right? Because we want the zippy experience for the user. So at some point, the user is going to go from that screen to another screen. It's going to briefly go through a pause state, and that activity is going to end up in the stopped state. So basically, we can have many activities in this state at any point in time, right? They're basically sitting there waiting to either get resumed and brought back into running or killed at any point in time. So it's basically up to the system to decide when to get rid of a certain component. This is also sort of interesting because most of us are not used to having the system just randomly kill processes and get rid of them. We're sort of used to memory garbage collector killing memory or freeing memory, but not destroying processes. And this is exactly what happens in Android. So it's a fully automatic mechanism for getting rid of your code from the process space. The reason why it's done this way is that these steps here, the path from cold starting an activity to going to actually making it visible on the screen, tend to be very expensive. There's a lot of stuff that needs to happen here. We need to start a new application, usually a new Dalvik instance. We need to load a whole bunch of classes. We need to basically inflate the XML for the UI. We need to display all that on the screen. So it's a very expensive sort of process. These steps here tend to be much cheaper. So that's basically why the operating system keeps old activities, old screens in the stop state, so it can bring them up back whenever it feels like. Or it can destroy them if it feels that they're no longer useful. One thing that I want to point out about this is that the names are sort of misleading. The fact that this is called the running state, it doesn't really mean that your code is necessarily using a lot of CPU. So it could be just sitting there waiting for a user to input something. Consequently, the fact that something is called stopped, it doesn't mean that it's not doing anything. Right? So for example, if you have a game that's still listening to sensor data and processing them, then that activity is actually quite CPU intensive and it's using a lot of battery. Right? So those are things to kind of watch out for. So you as a developer basically have control over these callbacks: on, create, start, stop, resume, destroy, and so on. And that's where you can basically intelligently turn things on or off and control within which state something is doable. So for example, if I wanted to use GPS and I know it's expensive and I want to limit it to just this state, I would basically turn it on in on resume, because all the paths into running lead through on resume, and I would turn it off in on pause, because all the roads out of that state lead through on pause. So you kind of have this control. So you control the transitions, but not the states themselves. Now, activities are the most heavily managed out of all the components. So I kind of started with the hardest, but the reason why I did so is because they're the easiest to grasp, because they're visual. Everything else is not visual, so it's a little harder to kind of wrap your mind around. These are the callbacks that we talked about. So create, resume, pause, start, stop, restart, destroy, and so on. So those are your lifecycle methods. Now, whenever you create one of these main building blocks, you have to register it. You do this in the manifest file. It could be as complex as this, or it could be as simple as that. But basically, it's a one-line XML that basically says, hey, I have this new component. The point is, all the main building blocks, activities, services, providers, and receivers, must be accounted for in the manifest file, so that the system knows you have them. Now, since we're talking about activities and they represent UI, I just wanted to mention that when it comes to UI, there are basically multiple ways to build UI in Android. This is also sort of something that's unique about Android. So you have two ways you can approach UI development. One is declarative. And by that, we mean you build UI using XML. It's actually just drag and drop tools. It looks very similar to using something like Dreamweaver, for example. So for example, if I open up one of my layouts here, maybe my status activity, you kind of get this really friendly drag and drop tools where you can just pick the button once it loads up from the set of tools, and you can just, for example, take something, drag it, and drop it and make a use of it, for example. So that's the declarative approach. The result of that is basically a bunch of XML, sort of similar to HTML. Now, the other approach is programmatic. So basically, you program your elements in Java. Just like for those of you who used AWT or Swing, the concepts are very, very similar. So basically, Android offers these two approaches. The best way is to basically use them both. So let's take a button, for example. The fact that the button is blue and big and has rounded corners and font of size 25, for example, well, that's very easily described using XML. So the Dreamweaver-like tools in Eclipse are actually very useful to get you going with that UI really quickly, right? On the other hand, what happens when you click on a button, you can't really describe that in XML. XML is not the right tool for that. So that's where Java kicks in and becomes a really good tool for doing so. So basically, this dual approach makes UI development rather quicker, much quicker than it was in plain old Java, for example. Just like in Java, your UI is based on a composite pattern. So basically, you have layouts. In Java, we call them containers. And you have views. In Java, you used to call them components, right? But basically, by assembling these components, you build your UI. For those of you familiar with the web, it's kind of like a DOM tree in your HTML. The next part we have in building this application, in this architecting this application, would be to basically introduce a main activity. So the main activity is actually going to be the entry point. This is going to be our new home page. Before, the entry point was here, but you couldn't really easily go anywhere from that screen where you can just post your status, right? So the application before, in part one, was basically just this single page. and there was no place to go from there. So what we're introducing now is we're introducing this main activity with so-called action bar, which is basically this part of your application up here, where you can basically add buttons and things of that nature to help user navigate through your application. You can think of it as a navigation in a website. Now, what's interesting about the navigation is the use of intents. So in Android, we have a concept called intents, which are basically lightweight messages or events. And that's how we communicate between these loosely coupled components. So this is true for activities, services, providers, and receivers. They basically connect using intents. So that enables that loose architecture to begin with. So for example, an intent could be to jump, if I'm in one application, so I draw applications as these vertical stacks, right? So if I'm in an application called Gmail, and I'm inside of one activity where I can see the list of my messages, then clicking on a message may take me to another screen where I can see the actual message in Gmail, right? So I'm reading this message and I see there's a link to a web story, a web article. So I click on that. That now jumps to a whole new application, a web browser, and opens up an activity in which we render that HTML page. And in there I may see a video and I click on that, and that may take me to a YouTube, for example, where I can actually see that video. So essentially, I as a user just completed a task, but I ended up going through multiple applications and even more so activities along the way. So it's very similar to surfing the web. Yes, Ron? Can you go from a web browser to a native app? So basically, in Android, you never you go to another activity, right? So even if you went to a web browser, you went to an activity inside of a web browser. So it's just like I use a website as an analogy, right? So if you guys, like for example, if you go to CNN.com, can you actually go to a CNN.com website? Well, you can't. You can go to a page within CNN.com website. The website itself is just a container for a whole bunch of pages. It doesn't make sense to see a site. You see a page within a site. It may be the home page, right? So similarly, if it's a web app or a web browser or anything like that, if I'm jumping from one screen to the next, I'm simply opening up another application that, and inside of that, I'm seeing another activity. Does that kind of make sense? A link in a browser can be an intent. Yes. Yes, yeah, there is a way to do that. So basically, links in a browser can cause opening, be an intent, basically cause opening an activity. For example, any of you dealing with OAuth authentication, you kind of have to deal with that. So you kind of jump to OAuth to authenticate your application, then you got to get back to your application. It's tricky, but it's doable. So that can be done, yes. One point I wanted to make about intents is that they can be explicit or implicit, which is kind of interesting. So in this case, I'm spelling out that opening up a message in Gmail is going to cause Gmail's internal activity to render it, right? So I'm being explicit. But in this case here, I don't care which browser handles the opening up the URL, right? It's user's preferred browser. So if a user has Firefox or Chrome, well, that browser is going to open up. So we're being implicit. We just want the page opened up, all right? So that's a neat thing about Android, because you can basically, using that approach, you can replace applications. You can have multiple SMS clients or multiple calendars, etc., which is unique to it as an operating system. You can use intents to do just a handful of things. Start activities, start buying services, or send a broadcast. So it's not like the whole bunch of other things that you can do with intents. An intent, just kind of like briefly on the code, an intent simply may look like this, where you spell out that you're going from this context to this activity. So it's kind of like an HTTP link, right? It's not really a from and a to, but you can kind of think of it like that. Or another way to specify an intent is to basically specify so-called action. Now, action is nothing more than a piece of text, right? So basically, it's a piece of text that you're saying, I want some action handled. Well, if you have some action that you want handled, hopefully somebody is handling that action, right? So there are a whole bunch of system actions, such as open up a dialer, make a phone call, take a picture, etc. But you can also create your own actions. or action handlers, or so-called intent filters. So intent filter is basically where you say, all right, I'm going to be the guy who handles that action. So basically somebody is dialing a number, somebody is answering that phone call, right? Yin and yang. So otherwise it's not gonna match. So intent filters are the opposite of intents. So now that we know intents and all that, we can introduce the action bar, which is basically the navigation. So action bar is your glorified menu system. In the old phones, it was hidden behind the physical menu button, if you remember. In the newer devices that don't have buttons, it's the action bar at the top. But from coding point of view, it's basically the same thing. So action bar was basically overhauled in API 11, i.e. Honeycomb, and that's when they introduced no physical buttons and the new navigation at the top. But that's basically just kind of a cosmetic change. From a user standpoint, the code is the same. So if you ever worked with menus, it's nothing really changed, other than there's a new parameter that says, do you want to show it as an action, and you can control which buttons actually show up, which don't, since presumably you can have space for just about everything. The real estate is limited. So now we have the third part of this is basically to create a service. So far we talked about activities as the main building blocks, and I mentioned there are 4 of them, right? So service is the next one that I'm going to talk about. So in our context of Yamba application or Twitter application, so far we have a way to post to Twitter, right? No big deal. Now, we may want to occasionally pull from Twitter. So basically we may want to have something that is cranking in the background, always on, always running, and periodically going and checking, hey, are there new tweets, right? Or what's my friend's status? Or whatever that something is that you kind of need done in a background. So in our case, in this example, that's the motivation for introducing a service. So we have a service as such component. That's what it's designed for. So it basically periodically goes and pulls the data from Twitter and figures out what's going on. Now, services, like I said, are processes, things that run in a background. I'm putting background under quotes because it's a trap. The word background means different things to different people. What I mean by a background is I mean you can't see it. There's no UI to it. What I don't mean by a background is that it runs on a separate thread. Okay? So it's not like in the Unix terms background process. None of that. As a matter of fact, your services by default run on the same thread as your UI. So for example, if my Twitter app was actually pulling the data, and while it was pulling the data, I happen to have a slow connection, I would notice that in my UI. But it would be really hard to figure out why the UI is sluggish. And it would be sluggish because of something that's happening every once in a while and you can't see it. So, and it depends on the network. So it's a really hard bug to find, really hard thing to profile. So be kind of mindful of those things, that your services run on the same thread as your UI by default. So an example of a service would be a music player, right? So say we want to build a Pandora or Google Music or whatever it's called, and obviously we need the UI. We need somewhere to pick the station, give it thumbs up, thumbs down, and so on. But at the same time, we don't want to own the playing of the music here because this could go away at any point in time. Remember, activities just get disposed by the system as it feels like it, right? We want the music to keep on playing. So what we can do is we can actually own the playing of the music in a service, right? So this guy comes, starts the service, goes away. Later on, this guy reappears, stops the service, and goes away, right? So that's basically the idea. So the services are way less managed than activities. So the lifecycle of a service tends to be much simpler, right? You, for the most part, start it. You, for the most part, stop it, right? So that's basically a simple service. That's how it works. Now, services can be bound and can be unbound. Bound services are much more complex. They require use of something called binder and AIDL. There's going to be a talk later on today about how to do that. I'm talking about unbound services, which are much simpler. So what that means is that the lifecycle of a service is not dependent on the lifecycle of a client. So the client can go away, come back, the service keeps on cranking, right? So that's basically a service lifecycle. Callbacks for a service are pretty simple, much shorter list than activities. You create and destroy is basically universal pretty much, right? So that's where you do something initially and that's where you clean it up. And then the main method in this case would be on start command. That's where you do your actual service work. Now this is a service. I want to introduce the intent service as a cousin of a service, which is basically a type of a service that happens on a separate thread, as a matter of fact. So as such, I really like it because it's designed so that I don't need to worry about dealing with putting stuff on a separate thread and dealing with a non-blocking UI and getting rid of application not responding errors and so on and so on. So it's a very useful type of a service. It's very similar. It just has a different method on handle intent. That's where you do your work, the background work. And it's truly in a background. It actually happens on a worker thread. But for the most part, it's a similar use. Just like activities, once you create it, you have to register it. Sorry? Intent service, yes. Yeah. What I'm saying with here is that, for example, if I'm refreshing my tweets, and in this very example, so when I click on this refresh button, what that does, it actually causes this to run, and this in my refresh service, and that's where I actually do the pulling from Twitter. Now we are subject to a very slow network, right? And we can't control those external parameters. So, but as you notice, my UI is responsive, right? I can keep on doing stuff in the UI, and it still hasn't possibly refreshed the tweets, right? You know, so but the UI is not being blocked. The UI thread is not being blocked by the fact that the network is running slow. The emulator is slow. That's another point altogether. But yeah, you can kind of see that there's some change. When the activity goes, the intent service is not going to go. It's unbound. So the service is going to survive activities. Yeah. Intent service closes, yes. So that's true as well. So intent service, once it's done with its job, it actually dies off. But that's independent of the life cycle. Exactly. As long as this job is not done, it's going to exist. When this job is done, this gets called automatically and the service goes away. But again, it's independent of whoever called it. Yeah. Can intent service be used for playing music as well? Not necessarily. So basically, the way I see this is this service is good, is useful for doing one large job in the background, right? Refreshing a tweet every once in a while. This service is good for an ongoing job that you want to, keep on going, like periodically sending a heartbeat to the mothership or pinging something or owning the playing of the music, which is not heavyweight task. It doesn't take a lot of resources from the service, for example, itself. So they're used for different purposes. So the question is it the one big job or a smaller ongoing work? Technically, nothing prevents us from playing music here. It doesn't. But when you are done starting the music player, this is going to go to a destroy. So then the question is, who's got a candle to that actual music player and who can shut it down? You could end up with an object that doesn't have a reference to it. So that's something to watch out for. A good way to, for example, use intent services that need to do something periodically, like refresh tweets, but that is a big, heavyweight job, is to use alarms along with that. So basically, you schedule an alarm that is gonna ping this service every, once an hour or so. And that way you can also align that alarm with all the other things that are doing networking, and that's actually a very good way to handle optimization for battery. Yes, you had a question? Is it better to use intent service or an async task? That's a great question because both are designed to help you with handling non-blocking the UI thread. Async task is something you launch typically from an activity, and the nice thing about async task is that allows you to basically update the UI once the task is done. So it's all about synchronizing the work that needs to happen on a separate thread and then updating the UI back once it's done, because that synchronization is the hard job, and that's what the async task is solving. So it's mostly about the UI. Like I'm downloading a whole bunch of files, and then I want to tell the user when it's downloaded. All right? That would be a case for a async task. Intent service is, I don't care about updating the UI. I just want something done in the background. There's no need for me to ping the user, and it's a service, so it doesn't even have access to the UI. Right? There's going to be a talk on concurrency tomorrow by Blake Mikey that discusses exactly these types of differences. It's going to be a really good talk. So, can intent service live on after the activity created? Yes, they're unbound. So the life cycle of the service and the activity is disconnected. Oh no, not if it's not going to live through the power down, but it's going to survive the life of the activity that started it or whatever started it. Yeah. If you're tracking GPS coordinates, depends on what you're doing again. So if it's something that's a heavyweight work and you want to do it like, let's say once an hour, you just want to figure out the location, log it somewhere, go away, there's no UI associated with it, you could use an intent service along with an alarm manager. So you set up alarms to ping it, to basically a pending intent, to kickstart it every hour or so, right? And that's what I use in this example. In the other case, you could also use a service and basically have it, so as opposed to having many instances of intent service, you can have just one instance of a single service, but inside of it, you're managing the threading yourself. So you can do it both ways. It just depends on the type of a job you're doing. Right, the service is the main thread, but you would have to manage the threading yourself. So like I said, we still need to worry about not blocking a UI thread. It's just that this was designed in such a way that they already did it for us. You stick stuff in here, and it is on a separate thread. So, it's kind of like pre-packaging all that hard work for you. So the question is, how does your alarm service work if you have pending alarms and the activity or whoever set up those pending alarms disappears? It really depends on how you set up your pending alarms, right? So typically, it depends. You may want that alarm to go off even though whoever set it up is gone. That's a legit request. Yeah. So you guys don't mix activities and applications. If you have a service, your application is not closed. Your application exists. It's a container for your service. It must exist, right? So your activity can go away. And if you have an unbound service, that unbound service survives it because it's got a separate lifecycle. Can local service start intent service? Anyone can start anything. Right? Anyone can basically, a service can start activity can send a broadcast receiver can kick off a service. It's just intents. So any of those four components, they can launch intents and fire up other things, yes. So those are two separate questions. When you click on a back button, what happens is your activity is just merely going to this state. So it's not closed, it's stopped, it's alive, it's cranking whatever it's doing. It's just in this state called stopped. It's a quasi-state. But it's in memory, it's in process, it's actually doing stuff. At some point, it's going to get disposed of, but we don't know exactly when. The service is going to be independent of that, so it's going to keep on running if it's an unbound service, yes. If the activity is destroyed, like I said, the life cycle of activity has nothing to do with the life cycle of a service if it's an unbound service. So this whole thing could never, ever even exist, gone. You can delete it from the phone, that's all I matter. The service is going to keep on cranking because it's got a separate life cycle in case of an unbound service. Bound services are different. Yeah, we can talk about it afterwards. So moving on to content providers. So basically, this is where we are in terms of the architecture, right? So right now we have that main activity. It's got a way to jump to status activity. We can post to Twitter. We also have a service that's periodically pulling stuff from Twitter. What we now need to do, store that data somewhere. Now, you could store it directly to a database, but the better approach is to actually store it in something called content provider. So a content provider is yet another main building blocks, so activity services, content providers. And a content provider basically is your interface to data. It hides the fact that it, as a matter of fact, uses database. The service is going to be dumping data into the content provider. The fact that it's using a database or possibly even going to another cloud, that's not relevant, right? So it basically becomes an abstraction to your data. So content provider is basically an interface to a data, right? It provides your standard insert, update, delete, and query methods. It normally uses a database, but that's by no means a rule, right? So it can use any type of persistence it wants, or none for that matter. So basically, the problem we're trying to solve with content providers is that applications are sandboxed, right? So each application is an island on its own. One application cannot see anything about the other application. That's the basis of the security model in Android. So basically, let's take an address book, for example. So you don't have one address book application. You actually have two, right? So basically, you have one that has the UI. There's an application called com.android.contacts that has your user interface. It's got no data. That's not where your people are. There's a separate application that you can't even see because it doesn't have any UI. All it has is a content provider with its internal database storage, and basically this UI application does insert, update, delete, and query into that application, right? So basically, when it comes to data, those are the only four things you can do to data, right? Insert, update, delete, and query. And content provider provides for that connectivity, for that decoupling of the data and the UI. So for example, if somebody else comes along and writes a sexier version of an address book with another UI, well, that application can also tap into the same data source, right? Or say, for example, you want an address book that actually figures out Bob's Facebook status and Twitter post and latest G+ update, as well as the phone number and the email and all that stuff. It gets a more holistic view of Bob, for example, right? So you can do it using this architecture. It's pretty decoupled and pretty elegant. Now, content providers have a very simple lifecycle. You basically just call insert, update, delete, and query against them. So the question is about, is it always database inside? Yeah. Does content provider have a database? Content provider is an interface to data, to a data source. It's up to you how you're gonna handle that. Typically, people use database, but so typically you would use a database, and Android has a built-in SQLite database, and they happen to make the API to a database very, very similar to API to content provider. So it becomes a very simple, elegant proxy. Well, depends on how you implement it, but it could be an elegant proxy to the database. Exactly, it could be easily integrated with the database, but by no means content provider has to use a database, and certainly not the built-in one. It could use a flat file, it could use a cloud, a web service, or anything you can come up with, yes. But it's basically an interface to a data. Yeah, the content provider tends to be somewhat harder to implement, especially if you want to implement it properly to handle all the URIs and things like that. So it's got those four methods: insert, update, delete, and query. There's also something called get type and so on. But implementation of content provider ends up being usually a lot of code for that reason, because of handling all the various MIME types and URIs that can come along. You still need to register it. One thing that's slightly different about content providers is that you have to provide the authority. This is how it's going to actually be known. So this is how you're going to be able to find it. So that's a little bit about content providers. Now, in the next sort of iteration, we're in iteration 5 of 7. So we're getting there, right? So basically, now we got a service that's periodically pulling the data from Twitter. It's stuffing the data in a content provider. The content provider happens to use a database for its backup mechanism, but nobody else in the system knows about that fact, right? What we want to do next is we want to actually display the tweets, what the status, what our friends are doing, right? So what we're going to do is we're going to use a list to basically display all the data. So Android provides something called a list, or list view, or list activity, or list fragment. But the problem that we are trying to solve is the fact that, let's take Gmail, for example. If you're like me, you may have maybe 10,000 messages, right? If you take all the archive messages, pretty reasonable to have a lot of data. So that's my data source. right? Now what I'm trying to do is I'm trying to display that on a screen that can display maybe 10 items. So there's certain logic that you need to do to intelligently provide all the data to the user, but not by sucking it down or doing some pagination or something like that. And that's where adapters kick in. So that's basically an Android solution to this problem. Yeah, that was a question. Right, so the question is, when would you use content providers versus just go directly to a database? It's a good question. I used to just go directly to a database, so it was like, why even bother about implementing this content provider? Especially, like I mentioned, to do them right, it's a bit of a work. And I also told you that the content provider only makes sense if you actually want to expose the data out. Right? So if I'm not exposing the data out, why would I care about content providers? That's a legit question, and sometimes this could be easier to just go there and just kind of do that and not even worry about this guy, especially if you don't have a need to share the data. I actually came up with the legit reason to have it in iteration number 7, in part 7, when we talk about app widgets, because you actually need to now expose the data outside of your own context. So that's a legitimate sort of motivation for it. But also lately, the tooling, the framework, has gotten much better about supporting content providers. We're going to talk about loaders a little bit later. And loaders work very elegantly with content providers. So they make loading the data very efficient on a separate thread, asynchronously, yada, yada. So those are the reasons why you would want to do it that way. It also helps keeping everything loosely coupled, because your application, hopefully it's going to become something significant and bigger, and you may want to actually start ripping it apart into separate apps. Maybe you have the data app and the service app and a UI app, right? So I'm seeing that happening out there. So those are the motivations for actually using it even in the smaller projects. Yeah. So the question is about observing content providers. Content providers, and we're going to talk about loaders a little bit. They make life simpler, much simpler. But if you want to know what changed, and remember how I mentioned there's a way to, the proper way to implement a content provider is to actually, when something changes, you send the URI exactly to the item that changed. The problem is that it's painful to implement it properly, and often people just cut corners and just return the default URI, and then you have no idea what changed. So the problem is really the developer's implementation of the content providers. But if it's in the same process, you can use, you don't need, you can basically use the observers, and that simplifies things a little bit. So, yeah. So another thing that I wanted to mention are fragments, because now we're basically want to build this so that it actually looks good, not just on a small screen, but on a big screen as well. Just to give you an idea of what a fragment is, basically fragments were introduced in API 11, and they correspond to a reusable pieces of UI, right? So basically what we have here is, in one case, I have a small screen, and what I would do is I would put my entire status activity, my entire list of what my friends are doing on one screen. And then you would click on it and you would go to another screen altogether. In the case of a tablet, I may actually have more real estate, and I may want to put the same components next to each other. So fragments are these reusable UI components, right? So basically you can reuse the same component, just package it differently. So that's one way to kind of think about it. And so that way your application can look great on both a small phone, a tablet, and a big screen TV, right? And I don't mean look great by, just on a big screen TV, just blowing it up or putting it in the top left corner. I mean actually using it, a responsive UI to build it. In this example, for example, let's think of the portrait mode as not having a small screen. So I can only see the list of what my friends are doing, and I would have to click on update button to actually send an update. But let's say I had now a bigger screen, which I'm going to cause by simply rotating the screen. And in this case, I have more real estate. It's still the same screen, but let's imagine I have more real estate. So basically, I would put one fragment here and the other one here. And as a matter of fact, the update button is no longer necessary. Right? So that's an example of reusing this UI. I just repackage it differently in a case of a bigger screen. Right? That's a fragment. Fragments were, that's what we talked about. The fragments, along with loaders, came basically in API 11 Honeycomb, and loaders are basically a way to load the data. So the problem that the loaders are solving is that you may have a ton of data. So loading the data becomes a job that could block your UI thread, right? So what you want to do is you want to do it asynchronously, right? So this is the loaders are solving the same problem as async task as is intent services. They're doing a heavy lifting on a separate thread and notifying you asynchronously of what happened, right? So they work in conjunction with the content providers. To use them, this is sort of how you use them in application. Now, loaders and fragments and all these cool new things are relatively new, API 11. And as you guys know, about 50% of the market out there is still using pre-11. So if you want to support older apps, older devices, what you can do is you can use the support library. You can basically package these things inside of your app so that they work. So your new code works on devices as old as 1.6. So that's a pretty cool thing via the support library compatibility package that we can do that. The final, second last thing that we have are basically broadcast receivers. Broadcast receivers are simple. That's a publish-subscribe mechanism. So say, for example, this refresh service, I want it always on, always running, right? When you turn on your phone, a whole bunch of things start. You don't see them, but Facebook started, Gmail started, Google Plus started. A whole bunch of services started when you turned on your phone, right? So one way to do that is using a broadcast receiver. So basically, you subscribe to a intent broadcast, in this case, boot completed, and you listen to that, and you do something, for example, start a service when you get notified. So it's basically a publish-subscribe mechanism in Android. It does. Yeah, this is an illustration. In this case, to use it for kickstarting our service, which is pretty typical. But you could use it to, for example, find out when an SMS arrived, or when your phone is running low on battery, or anything of that nature. So Lifecycle is fairly simple. You write a piece of code, you register it for some kind of intent, and then when that intent happens, you get a notification, right? So it's a publish, subscribe, or observable pattern, right? So that's basically what it is. The implementation is super simple as well. There's only one method, on receive. What do you want to happen when you actually get woken up, right? You need to register it, just like services, activities, and everything else. You need to register it in the manifest file. One thing that I wanted to mention that gets sometimes people get confused is that unlike services that are running, they're actually cranking in the background, right? Broadcast receivers are dormant. They're not doing anything. They're just sitting there until they get triggered, right? So that's a key differentiation between them. They're both things you can't see, but one is running a service, the other one is sitting there waiting for a notification, i.e. a broadcast intent. All right, the final part of this is basically the app widget. So I needed to, I wanted to showcase a reason why you would need a content provider. So I figured I'll introduce a widget. So you guys know those little things that you put on your home screen, right? Well, they actually don't live in, they're your code, you write them, but they don't run inside of your process. They actually run as guests in your home screen, right? So basically, one way to expose the data, or the only way to expose the data, would be to actually pierce the hole in your security of your app and provide insert, update, delete, and query to the outside world, right? And so for that reason, we use a widget as an example of how you'd use a content provider outside the dotted line, as you can see. This is sort of how you implement it. They're very similar to receivers, so I'm not going to go too much into implementation, but it's not that different than a receiver. And basically, you would get a widget like that you can put on a home screen that's now listening to the data from your own content provider. And that would be the reason why you would need a content provider as opposed to just going with the SQLite directly. So I'm going to skip through this. So basically, in the summary, I wanted to kind of introduce the activity services providers receivers as new constructs that are new and different and unique to Android, and basically how you would apply them to building an application. And I use Yamba as an example application, which I think is a really good sort of illustration. It's very comprehensive in terms of how all these different bits and pieces can play together. But architecture, as you guys know, it's more of an, it's part art, part science, right? So there are always going to be different ways to implement something, and It's only in the long run it's gonna, you're gonna see which one was actually a better choice. But as long as you know what these components are and how they interact with one another, you should be able to make good choices in your design. And again, keep in mind, just doing stuff in lines and circles as opposed to just worrying about the code. Once you get the design down using lines and circles, the code just basically comes out by itself. So that's the easy part. This is again, my name is Marko Gargenta. This is all going to be available on maracana.com, as well as I'll provide it to AnDevCon guys as some kind of PDF. But just so you know, I'll post it within a day or so. Yes, cool. Thank you guys. I have some books here for signing, so please feel free to come by, and hopefully you'll learn something today.